Don't ask.
Excited to do some calculus, nice. Okay, so here's a picture you could have, right? You don't have to draw the trees, you don't even have to draw the grass.
Oh, that'd be a good.
Although it is a nice touch.
We could use that x and 30 minus x.
Okay, so we know one of the poles is 12 feet high, one of them is 28 feet high, and they're 30 feet apart, right? Okay, so then, you know, the way that they set this up is we're gonna call, this distance is gonna be y, the distance from the top of the left pole to the stake, and then z is the distance from the stake to the top of the right pole. So w for wire, length of wire, our primary equation is w equals y plus z. Okay? Okay, problem is we've got two independent variables there, right? And those aren't even really the variables that we want. What's the variable that we want? What's the variable we control?
X.
X, where the stake goes, right? So we want to write this in terms of something that we can control because we want to know where should the stake be placed, right? So what we've got to do is we've got to come up with, we've got to be able to write y and z separately as functions of x, but that's easy to do because these are right triangles, right? So in the left triangle, what is y in terms of x? Well, I mean, we have Pythagorean, right? Yeah, good. 12 squared.
That, by the way. Cool.
Plus x squared equals y squared, right?
Yeah.
Everybody agree? So then y just equals the square root of 144 plus x squared. Okay. What about the other triangle? So in this one, we end up with 28 squared plus 30 minus x squared equals z squared, right? Okay, everybody agree? Okay, so then z squared is going to equal x squared minus 60x plus 900 plus, what is it? 784. So we're going to get 1684. Right?
Do we really need calculus for this?
Yeah, you definitely do.
Why? Because x and 30 minus x there? Shouldn't that be right there?
Shouldn't, what now?
Shouldn't you have the answer from the intersecting point right there?
But what's x?
9.
How's it 9?
Because it's a 3, 4, 5 right triangle.
Okay. I mean, how are you saying, how do you know it's a 3, 4, 5 triangle though?
Which one?
Intuition.
Intuition?
Good one, Brayden.
Okay,
You're a real
well,
superstar.
okay, I mean, you might even think, okay, the calculus book's gonna make this a little easy. So it's possible you're right, but if you are, it's an accident. So then,
Is that where you got 24?
Then we want z not z squared.
right, so we'll square root both sides,
Z
right?
not Z.
Z not z squared.
Z not Z. Squared.
Okay, so we get z and we get y, so now we've got this whole thing as a function of x, right? Okay, that's good. So w as a function of x is the square root of x squared plus 194. 44, you're right, 44.
50.
Plus that big square root.
Yeah, plus the square root of x squared minus 60x plus 1684, right? That's pretty ugly. Are we probably going to do a second derivative here? No. We're not going to do a second derivative. We don't need it. We'll use the first derivative test instead, in this case. Second derivative will not be convenient. So what's w prime going to do? What's this one going to give us?
So it's gonna be, so it's 1/2 times x squared plus 144 times,
To the
oh, to the negative 1/2 times 2x.
times 2x, good. Plus, how about this guy?
Negative 1 or 1/2. And then x
that thing good. Times,
2x minus 60.
right?
Wait a second, where's your other? Oh, come on.
Okay, so then we can combine those, red and blue make purple, right? So, the 1/2 and the 2 cancel. So this one's gonna give us x over,
Where do you have two?
funeral,
No, the two, like, where do you cancel it?
1/2 times 2.
Oh.
So we get x divided by the square root of x squared plus 144, right? We agree? Okay, plus, that's gonna make that a 2 and that a 30. If I factor a 2 out?
Yeah.
Plus x minus 30 over the square root of x squared minus 60x plus 1684, right? Okay, so then we want to know, yeah, we want to know where it's equal to 0, or I guess where it's undefined. Is it ever going to be undefined though? No, it's not going to be undefined, is it? Okay, because how could we show that? Well, this we can show pretty easily, right? X squared plus 144 can never be negative because x squared is non-negative, right? How about this one over here? Well, where did we get that from? We got that from this expression right here, didn't we? Right, so z would be the square root of all that stuff. Well, 28 squared is positive, and 30 minus x quantity squared is always positive, right? So we know that, just working backwards, we can see from this step right here that that can never be negative value. We could also use the discriminant. We could take b squared minus 4ac and show that that's, let's see, we could show that that's gonna be negative, which means it never crosses the x-axis, right? Go back to algebra 2, honors algebra 2. If the discriminant's negative, it means there are no real roots, therefore no x-intercepts, right? So we would then just have to know what's the value of this going to be for any value of x. And it's pretty easy to show that if we plug in something like 0, we get a positive answer, right? So it could never be negative. It can't cross the x-axis.
What
Right.
is it, discriminant again?
The discriminant's the part that sits under the radical in the quadratic formula, right? And so we remember the rule that we have for the discriminant is if the discriminant's positive, then look at the quadratic formula and it tells you everything you need to know. Then I'm going to get no i's. I'm going to get real solutions, and I'm going to get 2 of them, one for the plus and one for the minus, right? If the discriminant equals 0, then that's the case where the vertex of the parabola sits on the x-axis, and that goes away, and I only get one solution. Negative b plus or minus 0 is just negative b over 2a, right? If the discriminant's negative, well then obviously you're going to get imaginary numbers, and so you get no real solutions, right? Graphically speaking, think about what the zeros are, right? The zeros of a function are equal to the x-intercepts. The real zeros are, right? Because think what that means. Where the function equals 0 is where it has a y value of 0, right? If it has, therefore, the real zeros, if the real zeros are the x-intercepts and the discriminant is negative, there are no real zeros, and so it never crosses the x-axis. Either the parabola sits above the x-axis and opens up, or below the x-axis and opens down. Be easy to find out which one it is by picking the easiest test point you could and seeing what the sign of the function is. 0, right? If I plug in 0 for x in this quadratic function, obviously I'm getting a big positive number, right? It's way above the x-axis. Agreed? So no matter what, this is going to be positive, right? Yes?
Yeah, isn't the domain like it can't be negative? It's numbers.
Well, the domain is going to be, right, it's going to be, my point is it's going to be everything though, because there are no values of x that could make the bottom negative, right? They could make the, see what I'm saying? That's what we're showing, is that no matter what, this function, we just showed that this function right here is always positive value, right? So there are no values of x that cause problems, right?
Would it be dangerous
okay, I mean, yeah, it is. You're starting to get some intuition. You could say, yeah, there can't be some certain magical, right. So the other thing is, that was almost unnecessary in a way, because look at our original function. These same square roots show up in the numerator, right? And so we would have had to restrict the domain anyway. The only places that could have potentially existed that would have been critical numbers would have been where these equals 0 instead of being negative. But we would have really probably already had to do this heavy lifting to see what the domain is. And does everybody kind of get, I mean, that's a pretty sophisticated discussion we had, but does everybody get how we can easily show that there's nothing? There's no way that either of those two functions could ever be even 0, right?
Yeah.
Does that make sense? I mean, either by looking at this step right there, that's the easiest one, right? You can see there that if z equals the square root of all that stuff, well, that's positive and that's non-zero or non-negative, right? So the smallest this could ever get is 28 square root of 28 squared, right? And the smallest this could get is 144 if x is 0, right? Both positive, okay? So then the only kind of critical number we're looking for is the other kind, right? Does that make sense? Where the function or the derivative equals 0, right? So here's my derivative function, and it equals 0. So that's an easier thing to deal with. If I've got two terms, and I want to find out when their sum equals 0, what would I do in this case? I can make this pretty simple. What do I do? I mean, I wouldn't say, this is kind of a harder problem than I thought it was going to be. But we can do this, though. I mean, it's just, you can't get intimidated by math. You just got to, math can take you, right? I mean, you just got to be, inch by inch, you can get through this stuff. You can't. So what do you do? How are you going to solve this algebra problem? Think honors algebra 2. You must have done stuff like this.
We had Bedor.
Oh, come on, she's a great teacher. I mean, but you remember doing this stuff when you're solving a radical equation. What do you do?
Square by triangle.
Oh, well, we're
Yeah,
trying to
okay,
find where they
right.
have
So,
equals.
okay, good. So first step is let's move one of those terms to the other side, right? So we're going to get then, something like, let's just partition all that off. So we're working down here. So we got this term, we get x over the square root of x squared plus 144 equals the opposite of this one, right? Negative that. Well, let's just distribute the negative 1 and make that a 30 minus x. Be with me? Over to 30. Over the square root of x squared minus 60x plus 1684, right? Then we just cross multiply. Exactly. Okay. Why don't we go ahead and, before we cross multiply, let's just square both sides. We're going to have to do those two steps eventually anyway, right? We got to undo the radicals. So we remember how we did that. If possible, we'll isolate the radicals. If not, we'll just have to square both sides, right? But that's okay. When we square fractions, it's no big deal. We're just squaring the top and squaring the bottom. But I'm going to change colors because whenever we take both sides of an equation to a power, we could introduce extraneous solutions. We'll have to check everything, right? Remember these discussions vaguely? Okay. This is important stuff. So if we square this side, we're going to get x squared over x squared plus 144, right? If we square this side, we're going to get x squared minus 60x plus 900 over that, right? Agree? We good? If I square 30 minus x, everybody agrees I get that? Okay. So now we cross multiply. Okay. So we're going to distribute the x squared all the way through, and we're going to get, actually, yeah, let's do that. Okay. Oops, x to the 4th. if I cross multiply, let's distribute. So x to the fourth minus 60x cubed plus 1684 x squared equals what we get on this side if we distribute through. So let's add those up. I'm going to distribute the x squared all the way through. And watch this, it's pretty cool. Watch this little trick. X to the fourth minus 60x cubed plus 900x squared plus, if I distribute the 144 through, plus 144x squared,
Oh,
see, Nickel, minus, what are we going to get? It's real, I don't want to think about this. Somebody real quick in your calculator, put in 60 times 144. Oh, I can't help myself. It's going to be,
864.
there we go.
that's what you were thinking, right?
X plus 900 times 144.
129600.
And so then, this kind of stuff is just fun. This is so good. I love it. Okay, great.
I did.
Okay, so then what's all that nonsense become? So let's collect like terms. So on the left side, we get x to the fourth minus 60x cubed plus 1684x squared. Right side, x to the fourth minus 60x cubed plus 1044 x squared minus 8640x plus 129,600, right? So let's collect everything on one side, and look what happens. Some good stuff happens.
Ooh, true it, true it.
Look at that. Ah, what do you know, right? So now let's collect everything on the left side. We're gonna get a positive coefficient of x squared. We always want that.
640x squared.
So we're gonna get 640x squared. That's a pretty good number, right? Plus, oh, minus,
Plus,
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 plus.
Oh,
never mind.
no, you're right, plus, I'm sorry, plus,
Yeah,
plus
we're not crazy, you're crazy.
8640x minus 129,600 equals 0. We'll wrap this up tomorrow, how about? Ooh, we just got rolling. This is a good one. I'm gonna save
Pretty
this.
sure it's 21. I'd just like to point out that even if